So coming up, we're working on a bunch of stuff that has to do with coordinate planes. So working with coordinates, figuring out their slope, their distance, and their midpoints is what we're going to focus on. So first thing I mentioned was slope. And for the example coordinates on all these, the ones we're going to use are going to be 5, 9, and -7, -7. And the first thing you should do whenever you get those points is to label them x1, y1, x2, and y2. And that's mainly for bookkeeping purposes, to make sure we don't make little mistakes. Okay, so slope as a concept is always rise over run, but in the coordinate plane, that's finding the distance between the y's and the distance between the x's, and it's the ratio between those two. So I simply plug those in. And so I have y2 minus y1, so -7 minus 9. And x2 minus x1, and that's -7 minus 5. So I believe that's -16 over -12. Which will reduce to, the negatives cancel out, right? And these are both divisible by 4, so this reduces to 4/3. All right, finding the midpoint, the middle point of these. Well, if I want to find the middle of two numbers, I can remember that we just simply add them both, or take their sum and divide by 2. So the way that translates into these coordinates is x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So then as a coordinate here, once again, I simply plug these in. So x1 plus x2 is 5 plus -7, right? So 5 plus -7 divided by 2. And then I add the y's, so 9 plus -7. And that equals, what's 5 plus -7? -2, so -2 over 2, and then 9 plus -7, I think, is +2 over 2, right? So it's -1 and 1. Yep. And now finally we have the distance formula. And that is the square root of the x's. So I have x2 minus x1 squared, squared, plus y2 minus y1 squared.
That's so cool. Your little camera thing. I mean, the math's cool too.
I agree.
Probably no standard for the next couple of days. She's still sick. She's here, but not
Okay.
feeling good. So
Okay.
let me give you that heads up.
All right. So I plug these in, so I have negative 7 minus 5 squared plus, and then y2 minus y1. So I have negative 7 minus 9 squared. And I just simplify. So negative 7 minus 5 is negative 12. And negative 7 minus 9 is negative 16. Okay, so negative 12 squared is a negative times negative is a positive, so this would be positive 144. And 16 squared is going to give us 256, I think. Which will give us 400 when you add those together. And the square root of 400 happens to be a number. Square root of 400 is 20. Technically positive or negative 20, but distance can only be positive, so. At least for what we're using, it can only be positive. All right? So now, that's what I would consider the hard way, is doing this all by pure math. Now, here's the easier way. I expect you to be able to do both. Okay, we draw an xy axis. And our points were 5, 9, and negative 7, negative 7. And here's where, obviously, I don't have graph paper for you, so you can just watch. So you have to go over 5 and up 9, so 2, 4, 6, 8, 9. I think I counted that right. 2, 4, 6, 8, 9. Okay. And then we have negative 7, negative 7. So I go to the left 7, 2, 4, 6, 7, and down 2, 4, 6, 7. I'm going to get a ruler so that draws in nicely. All right, and here's our line. And let's check. So on my slope, I go up 4 over 3, right? That's what we ended up deciding what the slope was. So let's see, if I go up 4 and over 3, does that, if I go up 4 and over 3, does that check? Okay, so our slope is good. So you can do slope off of a graph. And this is just simply a good way to check your work. All right, now our midpoint is negative 1, positive 1, right? So negative 1, positive 1. Now, by my eyes, that looks correct. And there are different algebraic ways you could check. And I am not going to teach you exactly how to do this in that way. All right. So if you wanted to, you could simply measure that. So let's see, that's a little over 6 centimeters, right? And a little over 6 centimeters. So it looks like we're pretty much correct on that. All right, obviously, if you got something that was off the line, your answer would be wrong. And now so with slope and with distance formula is where I would say the graph is the easier way, quote unquote. If I draw in this right triangle, do you remember what formula helps us out with right triangles tremendously? Pythagorean theorem. I think I just misspelled that, but that's okay. A squared plus b squared equals c squared. So if I look at the lengths of these, I have 2, 4, 6, 8, 10, 12. So that's a length of 12. See where that number comes from right there? And 2, 4, 6, 8, 10, 12, 14, 16. So those numbers are going to show up. And it's because distance formula is just an application of Pythagorean theorem. So when I plug these in to Pythagorean theorem, I have 12 squared plus 16 squared equals RC squared. So 144 plus 256 equals C squared. Gives me 400. And to get rid of a square, you got to take the square root. And you end up with C being 20. Okay, so I prefer using Pythagorean theorem to distance formula. There's more mistakes you can make with distance formula, I think. I also prefer reading slope off of a graph to slope up here algebraically. But midpoint formula, I am going to ask that you always do algebraically because just eyeballing this is not near accurate enough. Okay? So while I want you to be able to find slope and distance algebraically, if you can only do the graphically, that's still demonstrating that concept. But you have to be able to do midpoint algebraically. And that's a little introduction to slope, midpoint, and distance form.